Okay, my friends, let's talk about assigning oxidation states. There are some rules that we can follow in order to do that. And so let's do that and practice it. And this should be very, very, very much doable for people. So um, let's go over these rules. Oxidation state for an element by itself is always going to be zero. Let's look at some of those over here. So chlorine, this is from our ALEKS. Chlorine by itself, no charge attached to it. That is a zero. Same right there. If I see something like sodium, sodium by itself, the oxidation state is going to be zero. Anything by itself. Now, you will see things like H2. If it is an element by itself, it is going to be zero. You'll see something like S8. S8 by itself is zero. Okay, those are the rules for number one. Way, way doable. Sometimes you'll get confused. Sometimes you're not being careful. So be careful. Do it right. Oxidation state for a monoatomic ion is equal to its charge. Let's come over here. Iron right here with a 2 plus charge. The oxidation state of iron 2 plus is going to be 2 plus, is a plus 2. Okay. Zinc right here. What is the oxidation state of zinc? The oxidation state of the zinc ion is a plus 2. All right, piece of cake. This is an easy one to do. The oxidation state of iron 3 plus is a plus 3. Though it's the oxidation state of monoatomic ions, not our polyatomic ones, but our monoatomic ones. For a neutral compound, the oxidation states of all the atoms have to add up to zero. Okay, so let's do that. The oxidation state for the individual atoms inside of an ionic compound is going to be equal to whatever those ions are in there. Okay, so let's look at some of these. I can see some over here. Here is copper 1 oxide. What's the oxidation state of both of those? So copper 1 oxide. What's the oxidation state of each of these? Well, for the oxygen, it is a minus 2. For the oxide, the oxidation state is a minus 2. For copper, the oxidation state is a plus 1. Those are the oxidation states of each of those. Oh dear, let's go back here. Okay, I'm just going to do some erasing right here. Because what I always like to do is just a little check. Because I know that the sum of the oxidation states for these have to add up to zero. So I always do a little accounting up top that I quickly erase when I'm done. And this is how I do it. I have one oxygen. Hope you can see that. 1 times a negative 2 is a negative 2. 2 times a positive 1 is a plus 2. When I add those up, they have to equal 0. Okay, so I've checked myself. I know I'm right. I erase that right away so it doesn't confuse me, and I just turn in my answer as the oxide's a minus 2 and the copper is a plus 1. Those are the oxidation states. Let's see if I have another one over here. If not, we can just here's a copper 2 oxide. So here's CuO. Assign oxidation states right there. Okay, I'm going to do it. Oxygen is always a minus 2. Copper, in this case, has to be a plus 2. That is the oxidation state. I'm just going to check myself using my method. 1 times a negative 2 is a negative 2. 1 of the copper atoms times a plus 2 is a plus 2. Do those add up to 0? They do. I feel good about that. And I am done. You can do this with any ionic compound like that. Okay, so that is rule number 3. For a neutral compound, the oxidation states of all the atoms have to add up to 0. For a polyatomic ion, okay, so for some ion here, the oxidation states of all the atoms have to add up to the charge on the ion itself. Okay, so let's just do a couple of these examples that we might see. Okay, so I see that there is a potassium nitrate. Right, that is a neutral compound, but I want to assign oxidation states to each one of these. Oxygen -2. The potassium has to be a +1. We know that. In an ionic compound, then the oxidation state has to be the charge of the ion itself. Well, that leaves nitrogen right here. So how are we going to figure out nitrogen? Well, I do it a couple of ways. I can kind of intuit what it is going to be. But I can say 3 times a -2 is a -6. 1 for the potassium times a +1 is a +1. So that only leaves nitrogen. In order for this to sum up to 0, then the nitrogen, I hope you can see, has to be a +5. Has to be a +5. 1 times a +5 is a +5. So 1 + 5 - 6 = 0. Okay, these are the oxidation states right here. A +1 for the potassium, a +5 for the nitrogen, a -2 for the oxygen. Okay, let's keep going, doing a few more of these. It's a good idea. Let's do this guy right here, CHCl3. So we got CHCl3. Wants to know the carbon, but let's just do all of them. Okay, for the chlorines, the oxidation state is always going to be a -1. For hydrogen, the oxidation state is always going to be a +1 in almost all circumstances. So what does that leave the carbon right here? Let's do this with our accounting up top. The way that I do it, you can intuit it other ways. To me, it's just a rule that I can do. 3 times a -1 is a -3. 1 times a +1 is a +1. So I can see here that my carbon has to be a +2. Why? Because 1 times a +2 is a +2. 2 + 1 - 3 = 0. Okay, let's do what the rule number 4 is really talking about here. And that is going to be something like, let's do HPO4, 2-. Let's do this one right here. Okay, so HPO4, 2-. Let's do our oxidation states. This has to be a -2. Hydrogen has to be a +1. And these have to sum not to 0. They have to sum to 2-. This is a polyatomic ion. The sum of the oxidation states has to match the charge on the polyatomic ion. Okay, let's do that then. So let me just write it over here. HPO4, 2-. I already said this is a -2. I already said this is a +1. I'm going to give you a second to think about what that phosphorus could be. But let's do just my accounting rules up top. So 4 times a -2 is a -8. 1 times a +1 is a +1. Now the sum of these has to equal -2 because that is the charge on the polyatomic ion. And so I hope you can see that this has to be a +5. Why? 1 times a +5 is a +5. So in my rules up top, a +1 plus a +5 is a +6. -8 is a -2. And then just so I don't confuse myself, I just erase those up here, and I report the oxidation states of each of these. Okay, for hydrogen it's a +1, for the phosphorus it's a +5, and for the oxygen it is a -2. Okay, so let's just go ahead and fill these in case you really want to do this at home. The nitrogen is a +5 here. We already said that. This is going to be a +2 oxidation state. This is also going to be a +2 oxidation state. This is going to be 0. Of course, that's 0. That's a +3 oxidation state. We already said this is a +2. For the oxygen here is going to be a -2. That's the one it's asking for. HPO4 2-, we already said that that's going to be a +5. Copper 1 oxide, that's going to be a +1. This could be a +2. It has to match the charge of the ion. And finally, the oxygen here is going to be a -2. All right, these are doable, my friends. They take a little bit of practice. There's easier ones and there's harder ones. Just in closing, if you want to do it, think about this from the dichromate. Cr2O7 2-. Okay, what does the oxidation state of the chromium have to be? This is already a -2. And figure it out. I'll write it in there. I hope you can see that it's going to be a +6. That's for the dichromate. All right, these are doable. Just take some practice. Shouldn't be much of a problem.